Let's go through our terrestrial biomes chart. Take a minute and read the definition of what a biome is. And the first thing that we're going to do is we're going to sketch the lines of latitude that separate tropical, temperate, and polar zone. So I'm going to show you a picture of some lines, and you're going to, on your paper, draw a line across like this. And you'll be able to label. So above here is a polar zone. So you would label polar. And then you're going to label a temperate zone, a tropical zone, another temperate zone, and another polar zone. So let's take a look at how to do that. So here it is, and I'll make it a little bit bigger here for you. So sketch these zones on your map. So draw a line. You may need to pause this video. Draw the blue dotted line here. Oh, let me go back, sorry. Draw this blue dotted line for the polar zone. So here above the very, very top of Russia, Greenland, the top of Canada, and Alaska and Scandinavia is our polar zone. And there's another one down here. So this is another polar zone with Antarctica. Then we have a temperate zone, which is from here to actually the pink, not the orange dotted line. It's the pink dotted line, which is the Tropic of Cancer, which is 23 north latitude down to the Tropic of Capricorn, which is 23 south latitude. So don't draw the orange lines. So between the blue and the pink is your temperate zone, and then all of this pink are the tropical zones. Draw a line here at the Tropic of Capricorn, and then another here, and in between the pink and the blue is your another temperate zone. So the southern temperate zone is not there's hardly any land down here, just a little bit in the temperate zone down here. All of the United States is in the temperate zone. Some is in the subtropics. Where we live, we are temperate in California. So take a minute, sketch and label, and these zones are helpful in understanding biomes. Again, pause the video as you need to. The first biome we're going to fill in is the temperate seasonal forest, and another name for it is a deciduous forest. So on your chart, fill in these major locations: Europe, Eastern China, Eastern North America. The Great Lakes have seasonal forests. In the chart that says rainfall, it's high precipitation throughout the year. Fill in the climate: warm summers, cold winters with freezes, and that the leaves fall off the trees, which decompose and make fertile soils. So this biome has a dormant season in the winter, which means that all winter long nothing's growing. Well, not very much is growing. And so the leaves will decompose and add nutrition to the soil. So let's take a look at your paper. And what you're going to do here is you're going to write here the locations, and you're going to shade them on this map in just a minute. Fill in the rainfall, fill in the climate, fill in the features. And then when I get to the slide with the map, you're going to fill in with a colored pencil somewhere. You're going to fill in and shade the major areas of this biome, like that. So let's go to our slideshow. And again, pause the video if you haven't filled in the words to fill in the boxes. And I'm going to go on to the map. So here's the map. Shade the locations of this biome on your chart. I recommend in a color because the map is a black and white map, and the color will help you. Pause your video while you do this. Let's go on. The next one is temperate grasslands. And most of our temperate grasslands is gone. It's turned into agriculture. We call this place the prairie in the United States, and even in Canada. In Russia, this biome is called the steppe. And it's limited range, so it supports grasses more than trees, but there are some trees, especially near rivers. It has some extreme climate. Places like Nebraska and Kansas and North and South Dakota and Minnesota, they get very, very cold in winter, but also very hot in summer. So the features, some important things is that very little has remained. I mean, less than 1% of the original grasslands remain because most is turned to agriculture. It's the breadbasket of America. It grows most of our grains, wheat, soy, and corn that we turn into bread and crackers, and corn and soy is in almost every processed food that you buy, and also animal feed. And then, so the top picture is mine of a trip I took to Kansas. That's wheat, and there's some grass. And then the bottom picture shows historically we've had buffalo, huge buffalo herds in the prairie. What you need to know also is that thousands of years of decomposing grass and buffalo poop has made this soil extremely fertile, which is why really it was turned into farmland. Pause as you need to. Now go ahead and shade in the major areas of this biome on your chart. Pause the video to do so. Let's go on. The temperate rainforest. Now, a lot of this area in the Pacific Northwest of the United States is temperate seasonal, but some of it is a rainforest. So it gets more rain and milder temperatures. Southern Alaska, if you've ever taken a cruise up to Alaska, so places like Ketchikan or Skagway. I've never been, but I've heard it's beautiful. They are temperate rainforest. Japan has some too. Abundant rain and mild temperatures year-round. A lot of it are old growth forests, and it's important for biodiversity. A lot of it's been logged as well. Again, pause the video as you need to. So this one is not very much shading at all. It's just right here along the coast of California, Oregon, Washington, in British Columbia, Canada, up into Alaska, a little bit down here in South America along the coast of Chile, a tiny bit over here in some European countries, and a little bit over here by the Black Sea, and in China there is a little bit, and in Japan there is too, and then also you have New Zealand and parts of Australia. So way down here, if you look at your lines of latitude, this is a temperate zone. Not polar, it's temperate. These are about the same latitude, southern, as the northern latitudes in Canada and the Pacific Northwest. Going on to the tropical rainforest. That's my dog barking for attention. I'm filming Bluey. Okay, tropical rainforest. So in most places on the planet, it's going to be equatorial, means around the equator. So again, look at your map where the tropics are, between the Tropic of Cancer and the Tropic of Capricorn. Abundant year-round and hot year-round, it's by the equator. So it has the highest biodiversity on land. It's lush, it's dark, it's damp. The reason why it has poor soil is because it doesn't have a dormant season. So when something dies, a plant, a tree falls over, animals die, they're immediately decomposed because of the heat and rain and dampness. And so things decompose quicker with more rain and more heat, the higher the rate of decomposition. But because there's no dormant season, immediately plants are using those nutrients to grow bigger. So there's no nutrition left in the soil because as soon as nutrients are decomposed, they're immediately taken up by the plants. Whereas other biomes like our temperate seasonal forest have a dormant season. So those leaves can decompose, and there is time during the dormant season in the winter when things don't grow for those nutrients to go into the soil. So you notice here as you shade in this biome that it really is around the equator. So the equator here is, let me go back, sorry, is really here where I moved my cursor. Africa, this big band is about where the equator is. Over here, equator. Pause as you need to. Going on to the savanna. The savanna is mainly in Africa. You can see tiny bits in other places. It's low overall, but it has a rainy season. So because it's low overall, it's mainly grasses with these large acacia trees. Warm year-round, and again, when you have less rainfall, it supports grasses more than trees. And so let's take a look at that map. So you can see the most of savannas in Africa, a little bit in Australia and South America. So go ahead and shade in on your map, pause as you need to. The desert. The desert is in most continents, of course not Antarctica, but most other continents have some desert. So many places around the globe, usually at 30 north and 30 south latitude. In California here, we're 34 degrees north latitude, and while we live in a chaparral shrubland, right next to us is the Mojave Desert, and so it is at around 30 degrees north latitude. It's technically 34 is where we live. And that has to do with weather patterns that you'll learn in Unit 4. Rainfall is very low. You have extremes between winter and summer. It's very hot and very cold in the winter. Very hot in the summer, very cold in the winter. And organisms are specialized to survive. Now, some deserts are barren with sand dunes. Think of like the Sahara. Whereas ours, the Mojave Desert, has drought-resistant shrubs. Let's look at our map. So in the United States, here's our main desert areas going into Mexico. This big Sahara Desert here, this is Saudi Arabia, and you have other deserts in Asia and Australia, down here in Africa, and other places. So this top band is around, it's not exactly, it's around 34 degrees north latitude, and down here we're at 34 degrees south latitude. It's a trend, it's not a rule, but it's a trend. Pause as you need to. Let's go on to the tundra. Now this is a picture of tundra in the summer. The major location is high altitude surrounding the poles like Arctic and Antarctic. The rainfall is very low. Climate's very cold. Snow and ice in winter. The summer looks barren, but its vegetation is important. And I'm going to fix this little question mark. It's not supposed to be a question mark. It's supposed to be an arrow to show you summer picture. So that's the tundra in the summer, and it's really important for migratory species. Now, the tundra being so far north has very little daylight in winter, but lots of daylight in summer, which leads to abundant productivity. So you have all that light and so much photosynthesis that animals migrate there in the summer because there's so much photosynthesis happening, which drives very active food chain. And the tundra, you need to also know that its soil has always had permafrost, so permanently frozen soil, but with climate change and temperatures rising, that soil is melting. Now that may seem like a good thing, but it's releasing things like methane, another greenhouse gas. It also, the people and the species that are adapted there are adapted for permafrost. And when it melts, it's creating mud places for people and animals to get stuck. It's causing a change that they're not used to up there. So here is the tundra. It's right here in Antarctica and then all up in here. Now some of it's frozen, like you can see that this is Greenland, and where it's frozen here completely with ice, then it's not going to show. And same thing down here in Antarctica. But around the edges, where you're going to have some melting of ice during the summer, you're going to have this tundra. So go ahead and pause to shade in your map. The next one is the taiga. Another name for it is the Boreal Forest. Here's our major locations: Canada, Russia, Alaska, Scandinavia, very high altitudes and mountains of other biomes. Moderate rain, very cold winters, and mild summers. Long cold winters, short cool summers, conifer and evergreen trees like Christmas trees. Animals hibernate and then feed abundantly during the summers. Actually, while I'm here, let me fix that. So I'm going to fix that like that. There you go. It apparently was repeated. Going on. So you'll notice it's right under the tundra. So right here is where you have forests, but it's more sparse forests than your seasonal forests. So less trees, less vegetation. The trees are shorter, but they are forest. And Iceland is not full of ice. It's ironic because Iceland is green and Greenland has ice. The story is that Leif Erikson, the Viking who settled in these places, didn't want anybody else to settle on Iceland, so he called it Iceland. And then we have all here in Northern Europe, we have the Taiga. Again, it's just south of the tundra. Pause as you need to. Going on to shrubland, which is also known as chaparral. It's in Southern California, the Mediterranean, Chile, Australia. The rainfall is low, but more than a desert. That's why it's not a desert. It is the only biome with almost no rain in the summer. So that's one way to pick it out by its graph. Hot summers, mild winters. Has evergreen shrubs. Now, evergreen in this term, now, looking at this picture, and if you're familiar with the hills in Southern California, sometimes they look completely brown. But what evergreen means is that the shrubs are not deciduous. So evergreen is the opposite of deciduous, and so the leaves stay on the shrubs during the winter. This is a biome that's adapted to and also dependent on fire. There's a lot of species of plants where the seeds need fire to crack its seed coat and germinate. And so this is an ecosystem that, again, needs fire, wants fire, does catch on fire, and yet in Southern California, there's 20 million people living in this kind of ecosystem. But it's not the only ecosystem. A lot of forest ecosystems also need fire. Like sequoia trees, they need fire to germinate their pine cones. Very small, here's Southern California, Chile. We call, sometimes when you live in Southern California, they call it a Mediterranean climate because look around the Mediterranean Sea, it's the same biome in Italy, Spain. I was in Italy a couple years ago. It looked very similar to Southern California. Over here in the Middle East, in Israel. And then some in Australia and also in South Africa. Now let's make a climatograph. So a climatograph is a special graph that shows precipitation and temperature for each biome. It's important to be able to recognize patterns to match a biome with its climatograph. So on an exam, you may be asked, which of these climatograph represents a temperate grassland? And you'll need to be able to pick that out of an answer when it won't be labeled like this one's labeled. So let's take a look at your paper. Right now you're going to practice graphing. So go ahead and take this data, and on the x-axis you're going to put the months, and you're going to make a bar graph down here. So January, February, March, April, May, June, July, August, September, October, November, December. And on one side of the y, it says precipitation goes on the right y-axis. Oops, sorry, here's our right over here. Temperature goes on the left y-axis. You're going to do precipitation with a bar graph, and temperature is a line graph on the same grid. So here's your data. Go ahead and graph. When you're done, your graph will look something like this. And so the line represents temperature, and the bars represent precipitation. And this is helpful for us to understand the climate of a biome. So go ahead again and hand graph this graph, and then you'll be done.